we are in a time where we are facing a lack of stability. You see it everywhere. The world is like a storm. You have what we call perma-crisis everywhere. And the good thing somehow is that when you have a storm, you have energy. And this is exactly what we do in Nexans. We channel the energy. And what you have to know is that basically the electricity demand is growing by 25% before 2030. So you see it everywhere. You have the cities are swelling, you have a data center booming, you have electrical cars more and more in the streets. And at Nexans, we are not only witnessing the electrification of the world, we are, and we think we like to be the architects of it. But this revolution is complex, as you say, Chris. We need more power, but at the same time, we want less carbon. We want to grow, but we want to reduce the waste. And in all our education, very often we have been told we must make a choice. We must choose something. And in Nexans, we don't want. We refuse to make this choice. And that's why, as we said before, we have created this E3 model, which is economic, engagement, and environment. And this is basically the essence of the way we mix the business performance and the sustainability of our activities. To give some numbers, since 2018, the management team with all the employees of Nexans, we have been able to double our profitability. The market cap of Nexans has been multiplied by 4, and we have been able to reduce the carbon emission by 40%, which gives you the fact that you can indeed work at the same time on the performance in terms of financial, to work on environment, and at the same time to get the engagement of all your employees. And if we speak about engagement, we can move to innovation. Innovation in Nexans, it's not a department. It's all of us. It's a mindset. We like to learn, and basically, you know, we fail from time to time. And when we fail, we learn. And when we learn, and we know the solution, we accelerate. This is basically the way we work in this company. We are used to say that Thomas Edison, we have to speak about him when we speak about electricity, he has probably failed, what, 100 times, 1,000 times before he starts to see his light bubble working. And basically, this is what is innovation. It's not magic. When you have this perseverance, when you work under pressure, you are able to realize fantastic things. Now, if we speak about the infrastructure, the grid, they are basically above 50 years old in North America and also in Europe, which means that we must rebuild this grid. But we have to make them cleaner, smarter, and more resilient. With technology that we have, you know them, we have the solar, we have the wind, we have the hydro, but we have also to think about the new technology. Artificial intelligence, of course, everybody is speaking about it. Superconductivity, but also circular materials. And in our plants, we are already working on this. To give some numbers, at Nexans, we are today recycling 90,000 tons of copper. So it's not a small number. And we have the ambition to do much more in the coming years. We are also partnering in terms of artificial intelligence with pioneers like SenseWave. And I invite you to visit the stand over there. It's a fantastic tool that we are developing in partnership with SenseWave. And this is basically what we are going to engage in the coming years. So the next revolution is not only electrical. You heard a lot about this in the newspaper, in the information. It's also connective. And basically, all together, we stand at a crossroad. One path will be overconsumption, and basically it will collapse. The other is responsibility, regeneration, and shared prosperity. And Nexans, we have made the choice. We choose the impact over the volumes, we choose the meaning over the growth, and we choose the future over the fear. And today, in this short introduction, and before starting the discussion with the different panels, presentation, and so on, I would like to invite all of you to make the same choice, which is that all together, the actor of this electrification world, we built this world but in a way that is still be human in the way to handle it. Thank you. Enjoy your day and the evening.
Thank you so much, Vincent, for the remarks. It's clear we have a vision that is for the future that's optimistic and bold. Traits which are going to be necessary if we're to solve the challenges associated with electrification and decarbonization. Electronics and computing have allowed our world to become hyper-connected and digitalized. So what's next? The next industrial revolution will be marked by how we utilize that digital technology for the advancement and betterment of all humankind. To speak more about this and the role that digitalization plays in the grid, I'd like to welcome onto the stage Elliot Roux, Nexans Executive Vice President of Power Grid and Accessories, and Laurent Boineau, leader of the Americas Power and Utility team at Microsoft. Give them a warm welcome.
Hello everyone. Mic working, super. So I need to say good evening, right? Learning from the best. Okay, so with Laurent, we have the difficult task to try to drive you through a revolution. The revolution of the grid, the revolution based on data, artificial intelligence, but more and more about just electricity, electrons. So we try to answer many questions that I'm not going to list now. But first, Laurent, maybe you want to present yourself.
Yes, hi, Laurent Boineau. I'm Power Utility Lead at Microsoft.
So, Laurent, from Microsoft's point of view, how do you see the AI revolution on the grids?
So first of all, I'd like to start, because I sometimes get pushed back around, what does Microsoft bring to the table on this point? So Microsoft sees the energy industry in three main ways. So first of all, we are a big buyer of load, right? It's getting more and more obvious. We also supply the industry like we do for all other industry. But thirdly, and maybe more importantly, we partner with the industry. And we partner in two ways. We partner around innovation, not only with our customers, but with the broader ecosystems, such as yourself. And we also partner, again, with our customer and the global ecosystem, not on innovation specifically, but on policy towards decarbonization. So that's where Microsoft sits in the industry. And then in terms of thinking around the increased demand of energy, so just a few thoughts again. In Canada, the demand is driven by population growth, EV adoption, so electrification, and data centers. Within data centers, you have AI, but it's only one element of the whole story. And then, I'd love to share a little story, but I think if you want to think about the AI growth load, you have to think about what's actually going on in the labs. And you can simplify things by thinking about two labs. There's one lab throwing all the money, all the compute, and all the smart people possible at making incredibly advanced models. Those are the frontier labs. But right next door, there's another lab that does the same thing, except they take what was cutting edge a week ago and try to make it as cheaply, as lightly from a compute standpoint as possible. And so it makes prediction for demand incredibly difficult to predict, because you have not only to predict usage, but you have to predict the energy intensity of that usage. With small language models, that gets quite tricky.
Thank you, Laurent. So, there was the question indeed in the biggest gaps between today's grid infrastructure and the future. The future sounds very energy, I'm not sure if it is efficient, but at least it's going to consume a lot of energy, right? So I can just say that we are to address two main gaps. First, it has been mentioned by Vincent earlier. Today, in North America, the grids are getting very, very old. And at the same time, capacity is lacking behind. So in terms of figures, what do we have? We have 40% of the North American network that is already 40-year-old, right? And at the same time, we have to go to 80 million kilometers of grid that we have to build up, which is basically the equivalent of twice the worldwide energy network of today, which is also the equivalent of just multiplying by 2 the investment that everyone is doing on the grid worldwide. So the figures are quite staggering, because if I go back to the US and Canada, for instance, it means that by 2030, US will have, with data centers, twice the consumption in electricity. And in Canada, the EV vehicles will represent more than 20% of the sales of the vehicles by 2030, if I read what you are intending to do. Ontario electricity by 2040 will raise by 60%. Again, just some mind-blowing figures, and all of this driven by more data centers, more renewables, more EV, more heat pumps. On top of that, policy are lagging behind. What is happening today is that if you are a prosumer, meaning that you produce and you consume electricity at the same time, if you want to do it in one province in Canada, you cannot do it the same in the other province. So we don't have a unifying system to be able to regulate all those type of production. So if I would summarize the story, think of the grid as a backbone, an essential backbone in a body. And it's just like we're asking a half-century-old backbone within AI era to sustain all the loads that we are putting on it without a digital intelligence system and without the regulatory muscles that need to make it work. So the body, has to sustain that. And this is what we are putting on right now on our grids worldwide. So Laurent, if I go back to the innovation, meeting this demand, which is really staggering, will require innovation, right? Both in physical infrastructure and digital infrastructure. Nexans is advancing technologies like superconducting cable, but when it comes to cloud, AI, or data, what are you doing within Microsoft?
So we work with cables as well. So
yeah, you're right.
To zoom in on cables, we all, not here, not in this room, but most people think of electric cable as like a capacity going through some wires, but you can, actually that capacity has several limits and it depends on the heat, on the wind and things like that. And you now have systems, I believe, such as yours as well, that can predict the carrying capacity of a given cable in terms of the actual temperature. Thinking about temperature again, we have solutions like Aurora and Microsoft Planetary Computer, where you can take all the information, weather prediction information, into your Azure environment and your GIS, your Geographic Information System, and take pictures of pylons and then actually predict the exact type of trees and the expected growth of a tree or a specific bush depending on the weather, and for vegetation management. So you know exactly where to cut and how to spend as little as possible and be effective. So that's an example of doing more with actual, which was already built out there. Other examples like virtual power plants as well. If you think of the grid being a dimension for peaks, the VPPs can help cut peaks, demand response, things like that, and all that is about the grid becoming more intelligent and more reactive. But I can say a lot more.
You could say more. At least we have learned that it's a whole field actually to have AI on trees cutting. For real, last discussion I had with Enedis in France, that was about that. So, there is one question about whether we need to build new capacity or we could just sustain all of this with optimization of what we have. So, first of all, just to remind you that back to the investment figures, so Canada is going to invest $300 billion by 2040 into the grid. This is just mind-blowing. And you know that in the US, it's several trillions of dollars that are going to be invested. And when it comes to optimization, then you would say, yes, first it's very compelling to do a business case on optimization because then you can probably postpone this kind of investment. Yes, you can, thanks to grid enhancing technologies. So you have mentioned some of them. I will just give some other example. So for instance, we have dynamic line rating that it helps to defer the investment in capex on the grid, so everything that is new built. You have also what we do in Nexans, superconducting cables, already in use in Chicago, that allows you to have a huge amount of power in the cities without having to create additional civil work corridors. And last but not least, intelligence, digital intelligence multiplies the asset value of the grid because you combine AI with sensors on every hardware And what you get is actually the capacity to predict more or less every asset in their behaviors. For instance, preventing the partial discharge, which is the failure of the grid to happen, because you know it in advance. Final thing is that we have also the possibility to do smart planning with some of the solutions that Microsoft is doing to avoid overbuild. So you know that in the world of grids, we tend to do more for the peaks, but in fact, thanks to digital twins and AI modeling, you can actually avoid to have this overbuild. It's estimated to be a saving of 50% thanks to these digital twins. So in the end, optimization buys us some time. But it's not enough, because just to remind you that Canada has to double its grid in the coming years, driven by the implementation of data centers, EV on one hand, heat pumps, and all the renewables. So grid resilience will come from a smart infrastructure augmented by digital intelligence with AI inside. The two of them just augmenting the other to deliver faster, cleaner, safer, and also more sustainable electrification. Talking about cities, it has been mentioned before. There are a huge amount of energy consumed in the cities. So maybe if I can just continue on this, and then Laurent, you will tell us a bit more about what is your perspective on it. You know, cities, they consume 70% of the electricity consumption worldwide, and they are at the same time responsible for 60% of the carbon emission. So that's the perfect, what we call grid hotspots, to be able to test all the new technologies that we have when it comes to AI. I've mentioned some of them before, but in the cities it can be a bit different. We would talk about predictive operations to save on the outages. It could be managing EV thanks to AI, or doing vehicle to grid, like it's done actually in Hydro-Québec. And with AI supervision, then you can actually ensure that during outages, the critical services are still working, like for instance for hospitals. So back to it, finally, the main example would be that we are able with AI to create virtual power plants to be able to take grid flexibility into electricity capacity, to be able to save and cover for the peak demands in Canada, in the US, it's estimated to be 20%. So in the end, AI will enable cities to be massive adaptive energy systems by cutting, first of all, the outages by 50%, by limiting the peaks by 25%, and finally, by unlocking gigawatts of energy to be used by the communities. And this is thanks to data-driven intelligence. So how do we ensure that electrification in the end improves the quality of the citizen in the cities or elsewhere, and not just meeting the industrial needs like powering a data center? How do we do that, Laurent?
So for me, like just to double click on what you said, you mentioned Quebec. Hilo is a big project at Hilo-Quebec, and they've rolled out smart thermostat in people's home, and they're able to adapt smartly, like you said. So basically, cutting the peaks. And you were talking about cities and what we do in cities, but very close to here, you also have the first rollout of small modular reactors in the OECD. So that's a big improvement going forward if we can actually cut down the price of nuclear going forward. And something I haven't mentioned before, which I want to go back to as well, talking about how AI can contribute to kind of some of the increase in consumption that it's partially contributing to. We see generative AI used for permitting as well, which cuts delays in implementing new capacity on the grid.
So what we are saying is that electrification succeeds when we put communities first. What it means is that to ensure that electrification improves the daily life quality of citizens, we need to bring, in fact, the people at the center of grid modernization and planning. And with that, we can make this grid more resilient, more affordable, and also to create equity for the citizen. What does it mean concretely? So when I talk about reliability, it means really resilience thanks to predictive maintenance to ensure that we limit the outages. Affordability, it's thanks to smart grids, because then we can hopefully have a lower cost of energy. And finally, when you are, for instance, a solar prosumer, you can actually get money from your production that you deliver to the grid. So remember what has been said before. Electricity demand is going to rise twice by 2050. What it means is that the fastest way to make electrification improve the daily life is to use AI, to use smart grids, and this will enable us to extend the lifetime of the grid. It will help us to decrease the outages, and it will also enable the communities to share in the economical upside of what we have discussed just earlier.
Agreed.
You agree? Yes. So, you know, for sure, neither tech or energy can do it alone, and it takes us to what is core to our collaboration. And I was saying in the beginning that we are facing a revolution, but actually we need a revolution in the way we work together. So all of you here in the room, what we need is more partnering with vision-aligned strategic partnerships on new business model, innovative business model, but also on technologies. It was mentioned sense waves earlier, where we are investing as Nexans. So, you know, this is the kind of thing that we want to do, having a joint ambition to change the world together, to make it more sustainable with our engaged people and communities. But also, last but not least, we need more partnering with our policymakers, because we need to fund and execute locally on what it takes to get the grids to sustain what we have just explained earlier. And this is where it will take a lot of our efforts, and I'm sure that our collaborative efforts will have a big difference. And on your side, Laurent, what do you think we should do as a single call to action to the audience to accelerate all of this mechanism?
So I agree with all your points. I think policy is a big element here. My goal would be to limit the peaks, and I think intelligence is needed. You mentioned electric cars and virtual power plants. If you can switch the usage of electric cars to charging overnight slowly rather than peaks in the evening, for instance, you completely change what's needed on the grid. So less need for cable short term, but more stability, and I think that's the main thing.
Yeah, and in a way what we can understand from your point is a better education, right? Because yes, to educate all of us on an essential need, which is the grids. Maybe you have seen a few months ago for some of you, but that in Europe we have suffered from a major blackout in Spain and Portugal. And it's just reminding us how difficult it is to live when you have then no water, because no electricity, no water, you know, no data for the ones that cannot survive without Wi-Fi. But the most important is that hospitals, all the critical infrastructures, they are at stake. And this morning they were actually publishing that they see that they may face a similar event again in Spain, because they are again in a similar situation. And why? Because the grid is not at the level it should be. Like, remember what I said, huh? It's an old backbone, where we are asking a full body to do something that it has never been done before, both from the brain and from the muscle. So now I think I will hand it out for closing. So I don't know if I should hand it out to you, Chris. Yes? Yeah?
All right. Very good.
Thank you.
Thank you very much, Eliette and Laurent. Our first panel dives straight into the heart of the challenge of which Eliette and Laurent alluded. How do we meet the skyrocketing demand for electricity in rapidly growing cities? With over 80% of Canadians already living in urban areas, and billions more worldwide heading there by 2050, we face not only traffic jams, but energy jams. I'd like to welcome up on stage our moderator, Carol McLogan, CEO of Electrofederation Canada, to be joined by Riva Walia, Managing Director of France-Canada Chamber of Commerce, Pedro Barada, President and CEO of Habitat for Humanity Canada, Megan Lund, Senior Manager of Transmission Planning at Ontario IESO, and Pascal Radu, Executive Vice President of Nexans Power Transmission Business Group.
Thank you, Chris, and thank you to the panel before us. And you talked about the energy infrastructure being the backbone, but at the same time, you talked about the fact that this really is all about people, and people live in cities. So we know that there is going to be significant urbanization around the world, and meeting the needs of people within those cities and businesses is what this panel is going to uncover today. So I have an opening question to the panel, so listen up. Each one of you is going to give us your take on this. So as Chris mentioned, over 80% of Canadians are living in cities, and globally, that will raise to 7 billion people in the world will live in urban areas by 2050. Riva, from your perspective, what are the largest challenges facing cities as electrical demand surges due to this increased urbanization?
Thank you, first of all, to the Nexans team, Tim, Chris, Dixon, and Carol. Thank you for having us here and really talking about this very, very important subject. You talked about the numbers, which are staggering, and we're talking about numbers today in the next 5 years and 10 years, but let's fast forward to 2050. The biggest challenge that I see is the cost. And think about the cost of electrifying those cities, but if you think about it, it's not just the cities, it's also the extensions. I mean, we are here in Canada. Think about the reserves for the First Nations. So we have to think about equity and not just the people who are living in the cities only. I think the biggest challenge we face today and also going into the future is equity. Making sure that how do we bring everybody together to have better quality of life for everybody. That's where I come from, and that to me is the biggest challenge the world faces today.
Thank you. Pedro, you often speak on behalf of families and homes. How do you view this particular?
Hi everyone. I'll pick up where Vincent ended, which was to talk about how this transformation has to be human and how we have to power a whole bunch of things, but we also really have to power shared prosperity. And so this is a big challenge with big dollars and a lot of innovation and cables that will be required to drive the change. But we have to think about downstream, what is the impact around affordability? And we see it every day. At Habitat for Humanity, we make the dream of affordable homeownership a reality for families who otherwise would not be able to afford a home. And increasingly, those are not low-income families. Like, we're talking about the workforce of our cities, right? We're talking about bus drivers, nurses. We're talking about retail managers. Canadians are increasingly getting their housing costs to eat up half of their income. And there was a survey that just came out last week from MNP that looked at the rising impact of cost of living, incomes that are not keeping up with reality. And Canadians are now, 30% of Canadians are now reducing their utility bills just to keep their heads above water. So it's a case of heat or eat, and this is the reality that we're facing. And so as we move forward, we have big challenges ahead, big challenges. They'll be absolutely critical for our economy. They'll be absolutely critical for our future around sustainability, but we have to bring everybody along. And that has to be a challenge that is integrated in our planning and that we all work on together.
Thank you. Megan, as the electricity systems operator, how do you view this question?
I think one of the biggest challenges facing cities is around how to prioritize their goals against the limited resource that is electricity infrastructure. And specifically in cities where there's constraints on physical space and our ability to expand the system. And of course we want to renew facilities with bigger ones as they come to end of life and make the most of that. But there's very extreme competing demands that we heard about earlier from electrification, from EVs, from data centers, and increasingly also from industrial and manufacturing loads, which are much more energy intensive than we are used to them being. And if you're a city, you've got your own goals around climate, around economic development, and how do you use your utility, in often case, at least in Ontario, the municipality owns the utility or a portion of it. How can you, use your assets to meet your goals? And I think it all ties back to affordability too. Like a big part of doing that affordably is through the end user, through things like rooftop solar panels and energy efficiency. But if people can't afford to put food on their table, or if they're struggling to pay their rent, how can we expect them to invest in those assets? Like those are really kind of luxury purchases for a lot of households right now.
And as you say, luxury purchases, but it really is about the backbone, and it's the backbone to life. Pascal, your view from a Nexans point of view.
Look, I want to start. We've heard a lot of users, consumers today. Let's just assume we also all agree that it's a good idea to do all this electrification in a sustainable way. That means we have to put power production facilities online a lot more. And if we want to do that in a sustainable way, the only choice we have is wind, solar. We've heard it from Vincent, wind, solar, and a bit of hydro. We've also heard that the grid or the networks that we also basically using are quite old and not really ready for that growth, or for that different behavior. And when I think about that, my biggest worry is how do we keep a grid stable and resilient in that kind of environment where the production is going to be completely different. It's not the turbines, the gas turbines or the steam turbines that sort of run 24 hours a day in a stable manner. It's suddenly wind and solar, which are basically intermittent, as we all know. How do we accommodate that, and how do we stay resilient in that environment is really, for me, the challenge. All on the backdrop that we assume that it's a good idea to do all of this in a sustainable way.
And I think, as Canadians, we've been fortunate in that we haven't had, the resiliency issues that have been experienced in other parts of the world. But at the same time, none of us could imagine any time period without electricity. So Pedro, looking ahead, what is the one key action or shift in mindset that, if implemented, would have the most profound positive impact on balancing growth and sustainability in our power systems over the next decade?
So in these conversations, and definitely noticing, we talk about the big challenges, the mega trends, and some of the big technology issues that we're going to have to face. I think a mindset shift is, how can we help Canadians be a part of this conversation by thinking about their house as a way to produce, to conserve energy, and to also be part of how it is that we move forward together. And I think that's really critical, because it welcomes, it invites us to think about the design of policy, the design of implementation, how we create incentives so that every household sees their stake in creating the kind of future that we all want to see, and so that we're all rowing in the same direction. We see that as being possible, with also lots of challenges around implementation. Our business, of course, is to build affordable homes. And as we build affordable homes, we also want to meet and exceed sustainability climate standards. And we do that because we have great partners like the Electro Federation, like Nexans. So we have access to products that allow us to build much more sustainably. But how do you do that at scale? And how is it that as we move on these massive investments in the grid, we also think about how do we incentivize households to be able to have the panels and the heat pumps and the right insulation and all of the things that are going to ensure that the transformation that we need to see happens every day, and every Canadian can see it and be a part of it.
And I think, the average consumer, when you take a look at a heat pump, or, why would you change from your gas furnace to a heat pump, or why would you invest in different types of lighting? It always seems to come to the payback, and that's the driver. So that's where the affordability comes. But I think we also need to educate homeowners that, yes, there is a financial payback today, but there's also a payback for your children and future generations, because this is how they can contribute to alleviating that pressure on the grid, which we know that's going to expand so much.
Yeah, we got to bring everybody along. Of course,
That's
it's
right.
going to be easier for those who can marry the intellectual and mission-based argument with their
Right.
wallet. What are the other kinds of incentives that can help the public education and the implementation come along?
Unfortunately, wallet is king often, right?
Pocketbook.
So speaking of housing, affordability, and wallets, okay, so housing affordability is ranked among the top 3 concerns for Canadians. And we know it's also an issue in other parts of the world as well. What risks, Pedro, do we face if affordability is not built into the transition to smarter electrified cities?
I mean, it's about what kind of cities we want to create, and whether they're cities where there's social cohesion, where everybody belongs, where people are bought into the overall projects, or they become cities that are really divided between those who, you know, can live sustainably, have access to the right technology, and those who don't, and all of the risks that come with that. And unless we think about that proactively and on the front end and recognize that people are struggling and that people do need help marrying their, you know, pocketbook with, you know, what they would like to do, then where we end up is with political risks that, of course, you know, the general population is not bought into the kinds of investments that governments need to make, and that these investments are for all of us. If people are not seeing that as part of, you know, their reality, what's going to happen with their kids, their prosperity, the shared prosperity that you talked about, Vincent, that's a political risk that then has ramifications in terms of implementation through investment. I think there's also a reality of, you know, if we buy into the idea that all of us need to actually be rowing in the same direction and doing our part, as small as it, you know, changing your light bulbs. If all of us need to be a part of that, then leaving people behind and not providing them with a stake into this conversation simply means that we have more heavy lifting that we have to do. And so that's a key risk. I love that in this room, you're actually thinking very proactively about all the different perspectives that need to come together on the front end to make sure that these conversations are not happening in silos, but that we're building relationships, we're building shared understanding, and we're seeing how we can create a playbook that is about the triple win and the triple E that you were talking about.
Thank you. Riva, let's turn to you now. You're on the hot seat. So how do French and Canadian approaches to smart city development differ, and what lessons can we share from across the Atlantic?
Thank you, Carol. I think it's a very important question. As the world gets more fragmented, we need friends, and I think that's the role Canada and France have to play in the world today. And therefore, when it comes to electrifying the future, there's tremendous amount of collaboration that we can have between France and Canada. Back in 2018, I recall when we had just started the French Chamber of Commerce, we had wonderful French companies that were part of the chamber, and the government of Canada had just launched the Smart Cities Challenge. So very quickly we came together and we created a consortium between the French and the Canadian companies. It was so evident for me to sit outside that consortium and look at how people were thinking. The French were thinking planning, systems, logistics, timeframes, project. And there come the Canadian companies and the CEOs of large Canadian infrastructure companies who are thinking, how do we bring in other people and innovation into this? Is this inclusive? Where is the human relationship approach into all of this? So it was very telling for me that these two countries think so differently, but there is tremendous amount of power if we combine the two approaches together to create the next smart cities of the future, whether it's in France or Canada. And we did that successfully. And as that consortium, we supported 3 pitches that went into the Smart City Challenge. It was a tremendous success. But clearly different approaches.
Can you give us any more insights into some of the business collaborations around urban infrastructure or sustainability?
Yeah, for sure. I think Nexans is one great example. We've been working with Nexans on their business challenges. We had the pleasure of having Elliot in the past year in Toronto as well. I think Canada is, you said I'm on the hot seat, but Canada is in the hot seat with tremendous amount of potential that the country has for its growth. So being a part of the French ecosystem here, it's our responsibility to bring the Schneiders and the Acons of the world to come together to really look at those 2 different approaches, but merge them together. Smart cities is one example that we did, but currently we are in the process of working with the province of Nova Scotia on thinking about renewable energy with the help of a consortium of French companies very differently. And how do we just not only look at Canada, but the rest of the world differently, including our neighbors in the south. So a lot of collaboration, but all it takes is for one entity to really step out of what you are doing in your day-to-day operations. Think big picture, think country, not just your own company. That's what we've been able to create at the French Chamber of Commerce and the collaboration.
That's wonderful, thank you. So Megan, as the independent electricity systems operator, you manage Ontario's electrical system with real-time plans for the province's future energy needs. And we know that there are so many changes afoot and so many different considerations, especially with what's been going on with tariffs and the economy and everything else. How does the IESO work with municipalities and businesses to align energy planning with smart city growth?
Thanks for the question. So we have a really unique process in Ontario in how we carry out integrated local planning for the transmission system, where we not only work with the local distribution companies and the transmitters, but we spend a lot of time engaging with the community, including municipalities and Indigenous communities. And that's really key because it's the work the municipality is doing that's driving a lot of electricity demand in their community, whether it's their climate change goals or the economic development opportunities they're trying to attract to their municipality, which increasingly require a lot of energy. And this is really something I think that is helping bring municipalities really actively to the table in those conversations, is energy is becoming a top concern for them in terms of attracting those investments. And we've had this process in place now since 2013, and we've been building those relationships. And it's really starting to bear more fruitful conversations around, how does this demand forecast align with your needs? How do these solutions match up with your expectations around being able to continue to grow in your community, and unpacking those opportunities for non-wired solutions, which communities often want to see at the table because that's important to them to kind of manage the infrastructure needs in their community.
I'm a marketer at heart, so what you're telling me is that you're customer focused and you're doing things from the ground up, which is encouraging. As Ontario's energy system evolves, what are the most significant shifts that you're preparing for in urban electricity demand and supply?
I mean, the most significant shift we're definitely observing is the rapid uptake in how communities are growing. So we talked about how Ontario's growing at 60% by 2050. But if you look at how communities are growing, most communities we're planning for right now, we've got forecasts in front of us where load is doubling or tripling by the end of that 20-year horizon. And one way we deal with that is through scenarios to try to see how this might play out. But yes, I think the substantive growth from electrification and from EVs is really putting pressure on cities. And we're seeing that load curve. We talked a lot about shaving the peaks. That load curve is getting a lot flatter, like electric heating in the wintertime. EVs is really flattening that load curve and changing what those opportunities are to manage the peak. They're still there, but it's really an all of the above approach we're seeing to solutions where you've got wires investments doing some heavy lifting and then using that demand side to try to manage how much we need to invest in the grid and doing it all as one.
Another thing I'd like to talk about is weather. And you know, we can have a wonderful mild form of it, which has been extremely warm weather this fall. We still have our air conditioner on. You know, it's unbelievable. But really extreme weather events, which we're all concerned about globally. How are you ensuring grid reliability should those extreme events come along?
So at the ISO, we wear a couple different hats. So we're running the power system minute to minute. We've got our control room operators who are very aware of some of the extreme events that can occur and are dealing with them in real time and taking those lessons learned and running their different exercises to prepare for those types of events. But on the planning side, we're very concerned about extreme weather. So we've been taking steps over the last couple of years to really understand what those gaps are. We've been participating in industry initiatives like EPRI's Climate Ready to kind of understand both like the data and the planning improvements that we need as a system operator. And then really going after some of that low-hanging fruit. So how can we make sure our demand forecasts are not just reflective of the extreme weather we've known for the last 60 years, but are more reflective of the extreme weather we are and will experience over the next 20 years. How can we make sure that when we build a new transmission line that's going to last for maybe 80, 100 years, depending on where it gets built, that those wires are going to perform for us the same way 50 years from now that we're expecting them to when they go in the ground, because it is a thermally limited system. So these are the types of challenges we're trying to grapple with in terms of how we evolve, how we plan the system.
Very challenging indeed. Pascal, you, in your opening remarks, you talked about resilience and stability. What role can Nexans play in ensuring we have that resilience and stability?
I think you've heard in the previous panel. I think there's a lot going on in Grid and Connect to really, basically empower digital and data. So I think we've got a lot of products that can help us make the choices that we don't put the air conditioner on when we don't need it, and so on and so forth. So there's a lot of stuff that we can do here. I'm a bit biased because I'm the transmission guy here. I'm the odd one out. So I bring the power from far away to the cities. I think here we can really help, looking at these peaks and troughs and help the grid basically absorb those in kind of loads when you have peak and trough loads. But what we also forget quite often is that the grid is a sine wave. Okay, that has to be kept stable, otherwise it collapses. And for that, you need to have a certain power generation connected to it. And that power generation is basically a turning turbine. If you don't have that, then the grid will collapse. And that's not provided by solar or wind. Yeah? So you have to find a way of bringing that stable power generation to more unstable regions, and that's what we do in transmission. So I think we've got the products here to be able to really help that growth and accelerate it. And then the other thing, sorry, I want to add, because there's another thing we have, is knowledge. There's a lot of, we can do a lot of things, and there's a lot of ideas, but we have, I think, as Nexans, we have really the knowledge of how to integrate all of that stuff. How to integrate the transmission, the grid, and the connection afterwards. And that, I think, is a very powerful tool we have and we can offer to share with you and basically the rest of the cities.
I know that when we listen to utilities and so on, there's a lot of anxiety around the stability and being always on, and there should be, because that's what we're used to, right? When it comes to a message that you would like to deliver to governments around the world to enable stability and resilience, what would that be?
Well, there doesn't need to be anxiety. It doesn't need to be at all, because we have the technology today to make it happen. We have it today. And I think the message here is that, you know, like actually go out there and educate yourself what technology is there, and get it done. Just get it done. Stop discussing. Educate yourself. Take the technology and implement it in your cities, and then you'll be okay. I think there's a myth around there quite often that we think we need all this new stuff and technology. There is technology today that we're using that will help us getting this done. We just have to do it. There was a notion of legislation permitting as well, which goes in the same direction. It's really that we are much more conscious that we have to act in a much more agile way going forward and embrace the technologies we have, and also the kind of the technologies of the futures. But I think we have to start with cleaning up the myths that, you know, all of this is too difficult and can't be done, because the technology is here. We have to just want to do it.
So, I mean, you talked a little bit about permitting, and I know in our first panel, apparently Microsoft AI is going to help us with that, so that's encouraging. Pascal, you know, you mentioned that the technology is there, and is there any other good news that you want to share within the topic of the energy transition and electrification?
Well, I think the point that the technology is there is probably the best news we have. And I just can reiterate my encouragement for all of us to really look into technology with taking as the North Star the idea that we're trying to get as many watts for as little CO2 into our system as we possibly can. I think that should be our North Star. You know, we talked about the wallet before. What we forget in the wallet is the currency of CO2, because that we think is free today. It's not. It's just simply not. And I think that's one of the things that, you know, we're all conscious about it, and we're a little bit afraid to live with these consequences. And yet we shouldn't be,
Right.
because I think there's stuff out there that we can actually do now here, today.
I know that when we've had discussions with utilities and those in the electrification space, what I've learned over the last couple of years is that no one is disputing what needs to be done, that we're going to be doubling the size of our grid, that it needs to be resilient, that it needs to be sustainable. It's all around the how and how fast we can do it. And the other thing that they don't dispute is that the technology is not here. Everyone knows that the technology is here. It's just, let's get on with it. So that's, you know, the fact that there's that feeling is a positive thing. So the final question to Pedro, actually. So the summit highlights partnerships with organizations like EFC, France, Canada, Chamber of Commerce, and Habitat for Humanity. How can cross-sectoral collaboration between industry, government, academia, and community organizations be strengthened to achieve the ambitious goal of grid modernization and sustainability?
Pascal's confidence just, it really gives me optimism that one of the critical components of what needs to be true for us to move forward actually exists. But you may not know this by my young face in this picture, but I've been in and around public policy for about 25 years, and one of the things that continues to confound me is the delta between really good intentionality, great policy, and implementation, right? From a systems point of view, as the world gets more and more and more complex, there's technology, there's social license, there's sustainability. There are all kinds of factors, and we have a hard time marrying those effectively and efficiently enough to close that delta between the best aspirations, the best policy, and the actual implementation that marries, wait, I thought we were doing that. You're doing 50% of that. So I think a lot of it is one of the things that you mentioned, which is that culture eats strategy for breakfast. Or, right, you can bring people together from different industries. They will have different language, different interests, and the process of just coming together to figure out how do we build a shared playbook just requires real intentionality on the front end and throughout to make that happen. I'm actually hopeful to our friends at Microsoft. I'm really hopeful that technology like AI, one of the things that it can do is it can break down this gap between policy and implementation and just help us together model, look at different scenarios, do it faster, build together, and do it in a way where we find common cause and where we can get to shared outcomes and where that gap continues to close. Congratulations to Nexans for bringing together this group of people and starting to build those relationships, because in many ways it's kind of like the process is the outcome, and just being here together is how we start to get to know each other and to make sure that everything gets baked into the final cake.
I think that's a mic drop.
Right. Mic drop there. So, thank you guys. All great insights about the challenges we face locally as a result of increased demand for electrification. You know, I know the second panel is certainly going to have a lot to talk about after that. But first, we have held a competition this year in Canada in partnership with Electro Federation Canada and the University of Guelph. We've been pleased to host our first Nexans Innovation Challenge, a competition for students to present pitches on innovative product ideas and compete for a grand prize. They worked hard over the summer, producing business cases, personal statements, letters of recommendation, and the top 5 faced off at the Symes in York for a live pitch contest, kind of like Shark Tank or Dragon's Den. So check out this compilation video of the pitches.
The Nexans 2025 Innovation Challenge calls for bold thinkers to tackle the most urgent electrification challenges of our time.
Hello, we are StudyMed AI.
Hi, we're Icon.
We are excited to present EcoLumen.
Smart Grid AI tackles one of the greatest challenges facing Canada and the world today.
By adopting a line slot today, you're not just backing an innovative product. You're actually investing in the future of energy infrastructure.
All right. Okay, so the moment they've all been waiting for a while. Okay, so I'd actually like to welcome onto the stage Nexans VP of Innovation, Jerome Fournier. Okay, so Jerome is going to present each award as they are called. So without further ado, here we go. One thing to mention for the groups, just stay on stage when we call your group and come over next to me. Okay, here we go. In third place, with their AI platform designed to make distribution grids more predictive, adaptive, and resilient, Smart Grid AI. Okay, come on over. Stand right here. Okay, in second place, with their cold plasma surface treatment to extend the cycle life of lithium-ion batteries, Icon. Also, I love these trophies. These trophies are great. Okay, so to present the final award, I'd now like to invite onto the stage Tim King, the Managing Director of Power Grid and Power Connect North America of Nexans, and Riva Walia, Managing Director of the France-Canada Chamber of Commerce, to present us the first place team with a special award from the Chamber. Okay, I will grab these. All right, here we go. The moment you've all been waiting for. That's for Riva, and that's for Tim. That is a big cable. Okay. And in first place, drum roll please. There we go. For their autonomous clamp and drive inspection robot for distribution lines, Line Sloth. Okay. Picture time. Okay, take pictures. Good. All right. All the winners, picture. All right. Okay. All right. Yeah, guys, good. All right. Okay. Congratulations to all our winners and to the teams that participated. They've really worked so hard, to put together all these projects, and it's been such a pleasure working with the University of Guelph to make this a reality. Now, you've heard some of the challenges we're facing in light of an increase in urbanization. We've heard about some potential solutions and ways to balance the demand in cities, as well as some key insights on the impact that the surge will have on sectors like affordable housing and business. So now we turn to discussing how technology, regulation, and innovation can help us to modernize the electrical grid and truly electrify our future. I would like now to welcome on stage our moderator, Joanna Osawe, CEO of Women in Renewable Energy, to be joined by Hugo Lafontaine, Vice President of Industry at Schneider Electric, Chana Pereira, Vice President of Regulatory Affairs and Indigenous Relations at Electricity Canada, Kara Clareman, President and CEO of Plug and Drive, and Jerome Fournier, Vice President of Innovation at Nexans.
Oh my God, for those of you that know me, I love puns. So we're gonna start this off with a big pun. How electrifying are we tonight? Yeah! We're at the new era of Nexans. Thank you. I'm so thrilled to be with all of you. I'm so excited to be with our distinguished panelists and all of the distinguished guests. Thank you for listening to our panel, and quite frankly, like I said, I love puns, so you're probably gonna hear a few more from me, but I'm very excited. Bonsoir, je suis vraiment ravie d'être avec vous. C'est vraiment un temps tellement excitant. Moi, je parle québécois, fait que je m'excuse, Nexans en français, mais c'est québécois. En tout cas, on va y aller. So here we go. We're going to jump right into questions. And now, since I'm getting older, these are getting into handy. Right? Bonsoir, bonsoir. All righty. Chana.
All right.
We're going to start with you. And actually, before we actually get started, why don't we do a very quick intro? Hugo, Chana, Kara, and Jerome.
Absolutely. My name is Hugo Lafontaine. I am with Schneider Electric, a brother and sister company with Nexans from France, right? We're all about technology, energy. So I'm responsible for the portfolio on automation and technology.
Good evening, all. My name is Chana Pereira. I'm VP of Regulatory and Indigenous Affairs at Electricity Canada. Electricity Canada is the national trade association for all of the large-scale electricity companies across the country. Happy to be here.
Thank you. Kara Clareman, President and CEO of Plug and Drive. Plug and Drive is a nonprofit all about educating consumers on the benefits of electric vehicles, economic, environmental, health, and helping them make the switch.
And I'm Jerome Fournier, Vice President Innovation. I joined Nexans in 1997, and I'm so pleased to be here today with you guys.
So without further ado, thank you to Nexans, thank you to Tim, thank you to all of your amazing team to be here at the new era of electrification. We're here to discuss our panel, which is really the topic about grid, modernization, balancing growth, and sustainability in power systems. So we really need to take a deep dive into what that means into our landscape, what that means into our market. So I'm gonna ask the following questions, and I'm not picking on you, but I am. So Jerome and Chana, the first question for you is, let's define the challenges from your perspective. What is the single most pressing challenge in balancing the growing demand for electricity with the imperative to reduce carbon emissions and environment impact in grid modernization efforts? Chana, you can go right ahead.
All right. So I would say the single most important challenge facing us is building new infrastructure to meet rising demand for electricity and renew aging infrastructure. In my mind, there is absolutely no doubt that that's the challenge we have. Yes, it's going to be clean, intelligent, reliable, resilient grid in the future, but to make it happen, we first have to invest in infrastructure. And nationally, the conversation is about build, build, build. And for the electricity industry, it is no different. And we know nationally electricity generation will have to double by 2050. And then the provincial investment requirements obviously will be different depending on a whole set of factors in terms of population growth, EV sales, EV production here in Ontario, industrial electrification, a lot of money being spent on electrifying some of the key industrial sectors, data centers, we all know about that. And as I said earlier, the aging infrastructure. We would need to add new capacity as we move forward. And obviously, demand-side management, conservation will play an important role going forward to mitigate some of that increase in demand. And we heard earlier in the panel, the previous panel, that in Ontario, the demand is going to be around between 60 and 75% by 2050, because all of those factors I did mention will have a significant impact. So all that to say, once we build the future system, will not just have to be carbon-free, to Joanna's question, but we'll have to be smart. We'll have to be customer-centric. That will be crucial as we look at the distribution system and the role of customers. And we'll have to be resilient. But we also have to be flexible and be open to all options. Small modular reactors is one here, right here in Ontario. Interprovincial transmission is going to be crucial. Whether it's east, west, north, south, they're all going to be part of the mix. And as I said, the distribution network upgrades will be important in terms of optimizing the distributed energy resources. A couple of points I would like to make before I close. However, with the current investment climate that we have and the timeline for regulatory approvals, and concerns about affordability. These projects will take years to develop and commercialize. We would need the capital to make these investments, and somebody will have to pay. And in many cases, the money will have to come from the rate base. And the public finances are not that great, and I'm not entirely sure as to whether our governments will be able to afford to provide the funding in some cases for innovation that we need to have. But at the same time, governments can be enablers, not just financially, but with smart regulation, right? They can take decisive action to help expedite the generational, multi-decade projects that can contribute to our clean energy goals.
That really nails, everything that you just said, because I always say this at Women in Renewable Energy, les femmes en énergie renouvelable, fer and wire. Most people don't think about when we flip the switch in the morning. We don't think about safety. We don't think about reliability. We don't think about the performance on the grid. We, in this room, we definitely do, because we get it. But majority of the general public don't. And that awareness and education has to come from leaders as ourselves and leaders as yourself to understand and make sure that the general public understands what Nexans and everyone else is doing. So, Jérôme, à vous, monsieur, j'aimerais tellement vraiment savoir qu'est-ce que vous pensez de votre question.
What did you say?
Oh, ta question.
Sorry. I think the challenge, we all know the challenge. The challenge is the same for all developed economy, is expanding, modernizing the grid fast enough to meet the huge demand. And the question is not the what, I just mentioned it, is not the why. We mentioned EV and data center and heat pump and electricity. The challenge is the how to, as mentioned by Pascal. How are we going to do that in the next couple of years? And Canada is not an exception to the rule. The consumption is 625 terawatt per hour. It's going to move to 1,300, more than doubling. But the good news is the strength of the Canada grid, because it's one of the cleanest around the world. We have to do that keeping a low carbon and keeping reliability. So I think there is a good start for the Canadian grid with 60% hydro. There is a good start in the mix of the Canadian grid, which is good news. Now we have to take care about reliability.
As we're heading into COP30 and this goes into what you're talking about, net zero for 2050, which is going to be a very hard target for us to meet. This year, COP30 is taking place in Belém in Brazil. WIRE's delegation will be there, and I have to say that I'm very uncertain, and I think that we should all be uncertain what's happening within our landscape globally, because it is a global problem. And I do think Nexans, en français, Nexans, et en anglais, Nexans, but it is a problem that we can come up and resolve together. Kara, I do want to ask you this, because I think that this really comes back to, everything and anything. Can you talk to the audience about vehicle to home, and vehicle to everything and anything, to vehicle and grid, using different battery storage, and also different emerging energies. And or emerging technologies. I think that we need to understand and better welcome emerging technologies in this applicable world. So I'd love to hear from you.
Well, thanks, Joanna. Well, I think EVs can provide a really great example of sort of how new technologies can help address both issues of affordability and issues of reducing carbon emissions. So, as you mentioned, Canada's grid is already quite clean. And so we're actually already set up really well to make the transition to electrified transportation. And we can use that clean grid to take a huge bite out of the carbon emissions of our transportation system. So we're actually sort of ahead, I think, of a lot of other countries in that way. And then we could use those vehicles to actually help do peak shaving and reduce demand for electricity. So for example, here in Ontario, we have not only time of use pricing, but we have something called the ultra low. And anybody who has an electric vehicle like me knows about the ultra low, because at night, electricity only costs 2.8 cents. And so all of us with EVs, we take advantage of the ultra low. It costs me between 50 cents and $1 to fully charge my car at night. It's so cheap that you can't believe that everybody isn't doing it. So there's like a massive incentive there to help us do it. And at the same time, if we plug all those vehicles in at night, we've got a surplus on the grid at night here in Ontario because of nuclear plants running 24/7. So you have EVs balancing the grid. And actually, it should save money on the grid because, of course, those resources are going to be used 24/7 rather than, the ups and downs. And so there's so many benefits both to the consumer, to save money, to reduce emissions, and to help pay for the grid by adding this load at night when actually Ontario often gives its electricity away at night for nothing, or actually at a negative price. And so it's actually economically very beneficial to the province. So this is just one example of how, EVs can help solve a whole bunch of problems if we use them properly. And of course, vehicle to grid is another amazing opportunity to help us use our EVs. I've seen a bunch of studies saying, well, battery storage could really help balance the grid, but it's so expensive because you have to, buy these giant batteries. And if you take into account all the EVs sitting in people's driveways, those batteries are already paid for. And our utilities could come up with a program where they pay us to offer our batteries back into the grid. And I know in some countries this is already in existence. Here in Canada, it's really just in a pilot phase. But this is another way that we can actually shave peak, save money, and improve grid resilience, all while moving to a cleaner transportation system.
Well, I thank you, Kara, because especially with your Discovery Center at Yonge and Bloor, by the way, come and take a test drive, because you need to get your butts in her EVs and take a test drive downtown Toronto. It's scary, but guess what? And it's a lot of traffic, but we'll get there. Thank you, Karen. Hugo, on va y aller. Merci bien.
Québécois aussi.
Oh, toi aussi? Ah, c'est super. OK. OK. Sorry, the French Nexans. Oui, québécois, on parle un peu un différent dialecte, comme on peut dire ça. Mais en tout cas, all right, Hugo, on va y aller.
Let's be serious now.
Oh, yeah? No, really? Yeah. So as an electrical technology company at Schneider Electric, working closely with many Canadians' utilities, what is your perspective on the pace and challenges of technology adaptations in this sector? And what does that mean to you and to your company?
Yeah, very good question. So first, good news is there is an increased pace of adaptation around technology. Is it fast enough? Probably not. The challenge we have is we say grid modernization, but it's grids, right? Every single province, every single place we go is a different challenge. They have a different approach, a different vision, and how they want to get there. So I would say first is we need more unity, right, around how we want to adapt technology. The day that we have unity among all the grids to become one grid, imagine the power we would have, right? To do that, though, the challenge is we have to help the utilities to adopt technologies. Technology is the fastest way we're going to get there, and we've heard about how fast can we provide more power out there. And the reality is, when we engage with a lot of utilities, it becomes around software discussions, it becomes around AI discussions, it's around we have these 50-year-old systems that we need to keep running for a long time still. Yet we have all this data that is siloed, so we have problem leveraging that for the future. Then there's this whole discussion around DERs, right? Distributed energy resources. The reality is, when it comes to technology, adoption of technology is really around, there's three pillars why it works in an entity like a grid or like a utility or like many companies that are heavy industry related. You need people alignment, and that's a cultural shift. It's an innovation, like Nexans was talking about, like we adopt innovation. Schneider would do the same thing. Every single utilities out there understand that they have to adopt innovation and move faster in leveraging technologies. The second piece is the process. A lot of the way they control and automate their grid and automate their distribution, transmission, and also the distribution in terms of leveraging the microgrids and the emergence in the cities, for example, it's done in a way that unfortunately is not optimum. But to throw technology on it, which is the third pillar, and expecting that the technology is going to fix the process is erroneous, right? So it's an alignment between leveraging technologies, having the right culture, and leveraging the process optimization, which is done with AI, data, and all of that, right? So I'm seeing the progress. We are seeing the discussions going. Is it going to be fast enough? We have to do it, so it's going to happen. Is it going to be 2030, 35, 50? I think we all have a vision that, net zero by 2050 is where we're going. 2035, we need to have that innovation happening in terms of, doubling power output in some places. So the reality is we're having a challenge, and we got to get there.
I think that the challenge is all of us in this room and all of us in Canada and globally that we have to be hands-on. No more lip service, because lip service is free. Action is needed. Channa, and I really want to go back and what you just talked about, it was like, how do we get all hands on deck? And I want to talk to you, Channa, about, the labor force and the readiness of it. I also want to talk about Indigenous communities. To me, especially through WIRE, Women in Renewable Energy, les femmes dans énergie renouvelable throughout the world, we work very closely with Indigenous communities. And what does that mean? Because really, electrification in Canada and globally is going to be a significant collaboration.
Yeah, so in terms of collaboration, and I want to speak to the human capital component here, and I think to achieve this transition, we need people, right? And but the problem we have is that we don't have good alignment with the industrial policy that we have. So we need to find a way to connect the human capital requirements with the industrial policy. And the good news is at the federal level, they are coming out with a new industrial strategy for Canada. And I think it'll be very crucial that that strategy connects with the workforce strategy that we want to have to achieve the clean energy future that we are seeking. It is not just Canada investing in clean energy. The rest of the world is doing the same thing. And people have options to where they want to settle. And so Canada will really have to look at the human capital requirements and align what we're doing on climate change and clean energy. On the electricity side, Electricity Human Resources Canada published a report last year which indicated that this industry alone will need 28,000 more employees by 2028. That is less than 3 years to go. And then that is not accounting for nearly 30,000 that Hydro-Quebec is looking for to push through with their building infrastructure plan. So this is all happening at a time when our post-secondary institutions are struggling financially and cannot afford a diversity of programs. And the situation is unlikely to improve anytime in the near term. So I think it'll be important for us to kind of look at the low-hanging fruit. So if you ignore the funding part that we would require to support the clean energy transition, what else can we do as industry sectors, as governments and stakeholders? And some of the things that we need to start doing is to continue to promote that early awareness of careers in the energy sector, in high schools and so forth. We need to find a way also to modernize curriculums through more intentional partnerships with our colleges and universities. It is too late most of the time in terms of what we're teaching our students at our colleges and universities. We need partnerships with industry and academia. And I would say also consider faculty-industry exchanges, right? So they get real-world experience in terms of the various technologies we are talking about and so forth. So when they teach our students, they have a good understanding of the real-world applications. And finally, I'll stop at labor mobility is another thing that we need to focus on. I know many provinces are doing that, but we need to do it with speed and really enable labor mobility and recognition of credentials from other provinces.
You really nailed it, and I told you folks I was going to use puns tonight, so I'm going to use this again, a new era to electrify. We at WIRE started this really great program called WIRE Juniors Ambassadors Program. Actually, Carrie, you're part of that panel. We had two seven-year-old girls moderate a panel with 3 president CEOs, including Kara. How heartwarming is that? And I think that it's so important, like to Chana's point, we need to really electrify the future, pun intended again, and to make sure that we're really raising that awareness and being excited that this is an exciting place. Nexans is an exciting place. We are an exciting place to be at. So thank you for that. Okay, this one goes to Jérôme, Hugo, and Kara. So, and I know, Kara, you're going to talk about EVs, but this is open to all 3 of you. What emerging technologies, examples, advanced technologies, energy storage, BESS, AI-driven, grid management, smart inverters, virtual power plants, which are really important, hold the promise for significantly increasing grid capacity, while simultaneously enhances sustainability. What are the biggest hurdles to their widespread adoption? Maybe we can start with you.
Thank you. I think there are 3 main families of technologies to modernize and expand the grid. The first one is everything to do with interconnection. As you mentioned, Hugo, fully agree. We need to interconnect many regions and generation usage to supply, and which is a big challenge in Canada. That's probably a main difference in between the North American grid and Europe grid, because there is such a need for connecting east and west and maybe north and south, if you want to. You're not obliged, but
maybe not right now.
But at least what we see, if we have seen studying all the blackout that when there is interconnection, but that could be local one, you just decrease the risk of outage. There is technologies are ready. This relies on cable and cable systems, so if you want to place order, you're welcome after the panel. But there is not copper and aluminum enough to sustain the grid, so there is technologies to recycle copper and to reach 99.9% of conductivity. We have those facilities in Montreal. We have the same in Lens. We invest on those technologies. The second family is digitalization. As we mentioned, there is no way that we will invest only on infrastructure. and cable and hardware. So what we need is to better understand what's going through the grid, the flow. So dynamic line rating is a great technology to just balance the right flow within the grid, but also anything with sensoring. I mean, what we need is the Apple Watch of the cable, Apple Watch of the grid, and always knowing what's going on. And we mentioned SenseWave. We are so proud to have this partnership with SenseWave because that is a concrete example of AI. There is smart metering everywhere. Canada is 80%, and probably there is a need to move to 100%. But then when you get those data, and you know what is the usage, people per people, home by home, thanks to AI, you're able to monitor the flow from each single home or car or industries to the generators and the power plant or the hydro, which is amazing. So a good mix in between AI and sensoring and monitoring is one of the fantastic technology. And the third one is linked to the real mix of generation. The €1 million or dollar question is, what is the perfect grid? And I don't think there is one. Probably Canada is very close to, thanks to hydro. But there is a need in between, the good mix in between some hydro, some nuclear, some natural gas, some renewable wind and solar. And solar is probably the winner. It's going to be 80% of the new investment. But then battery, the best is absolutely mandatory to have a very well-balanced grid with all those type of technologies.
That's perfect. That actually really translates well into you, Kara, because what Jérôme just talked about, and I mean, I think the equity and the emerging technologies and how we accept technologies.
Sure. And so I think the second part of your question is the part I'll answer, because it kind of fits well with what you've just said, which is, what are the barriers to adopting these new technologies? And we survey Canadians all across the country when they come to test drive cars, and basically the barriers are always the same. They're, number one is cost, number two is, in the EV world, is range, and I'll say range is sort of similar to fear. And so a lot of these issues come down to education. The consumers don't necessarily understand new technologies. They're not aware of them. Many people that we meet, for example, have never sat in an electric car. They've never tried it. They don't know anything about it. They have an idea that it's not going to work for their life. They think it's too expensive. They think it's not actually better for the environment, and on and on. They think the batteries are going to end up in a landfill site. There's just so many concerns that they have. And so I do think, education has come up a few times today, and I do think we have to really work hard at helping consumers understand and accept these technologies. So that's critical. And then, the prices, of course, they are coming down. I mean, you look at solar as an example from, even just 10 years ago, solar is extremely affordable now. There are many electric vehicles now that are sub $40,000 in Canada. And in other countries, of course, even cheaper, and we would love to get our hands on some of those cars, but not yet for Canada. But, the price coming down combined with education, I think, is the key to adoption.
Anyone else have to comment? Chana, you go.
Well, I'll make one comment. So I think you've mentioned a lot of technologies. In my mindset, the future is decarbonized, digital, and decentralized. And I think a big reason why we're going to be able to achieve our goals and speed up is going to be our ability to decentralize, to have smaller plants. It could be SMRs. It could be the fact we can leverage energy at home, batteries, EV cars. It could be hydrogen fuel cells we have. The reality is the integration there that's going to really make it work. And integration is going to require some regulation. And the regulation piece is, clean power, the voltage regulation around it. How do we connect these things and not break something else in the grid? So I think the future is going to be around having that systemic approach of what we can do and how we do it. How fast can we install it and where? and then leverage the different technologies. Technologies are all there. We've mentioned many today. But the reality that the connecting thread here is going to be data, it's going to be AI, it's going to be the ability to connect with the home, the prosumers, the industrials, the hyperscalers, and make it work as one. And integration for me is, what I do every day. It's not easy, but it's the only way we're going to get there. So microgrid, decarbonization, integration.
Fantastic. And Channa?
Yeah, just a concluding comment then. Yeah, the technology is there, we can do it, but I think more fundamentally the question is who pays, right? The money is the biggest barrier that I think we have, especially on the electricity side. Many companies are cost recovery based, and yeah, you can borrow money from capital markets and so forth, but in most cases, many provinces monopolies, and the customers will have to end up paying for the investments that we have to make. And there is no choice, but we have to make those investments. And then we will need to have more tailored programs to support those who are going to be affected, because not making the investments is not an option. So I think that's the biggest challenge that we have as we look to our clean energy future. And I think the timeline, as much as we like to think about 2035, it is just 10 years away. And many of these projects take years, in some cases a decade. So 2035, I would say even it's not realistic, especially if you look at it from an affordability angle as well. People are simply not going to support having to pay $30, $40, $50 more per month for electricity over the next 10 years. So if we are going to do that, then we better come up with tailored programming to support our communities.
Thank you, Channa, and I definitely agree with that. I'm just wondering on timing, are we okay, or are we, Chris, we're good? Okay, good. So I can ask a few other enticing questions? Amazing. Well then, that brings me to cyber threats. Let's talk about those, because those are real problems that Nexans can actually really navigate. So, from a both critical aspect of a modern sustainable grid, like how do we actually, what can we do? Because I think that we need to actually work collaboratively to be able to make sure that our grid is secure. How can we do that? And especially because there's a lot of technologies right now that we're not aware of. There's a lot of jobs that we don't even know what are coming ahead of us. So without even and we don't have a glass ball to be like, okay, well, this is what AI or this is what, the new careers are going to be. But on top of mind, what is on top of mind for each of you we're all in the same sector, but in different segments. What does that threat mean to you, and how can we overcome it? Kara?
Okay. Well, it's hard to land on just one thing, but I do think actually it came up earlier. I think Channa talked about the issue of the labor force and having the workers. And it's a huge issue in Canada. It has been for some time. We've got an aging workforce in the electricity space. We've done a poor job on selling the trades to people. We start too late in educating people. In fact, when you talk about high school and university, even high school is too late. To be honest, here in Canada, you can opt out of science as early as grade 9. So you actually have to catch the kids in middle school if you want them to take science. And so we have to do a way better job here in Canada in showing the exciting future that's ahead, and to keep your options open and to take science in high school so that you have these options later. So I think that's something that is actually inexpensive to do and that we can easily do here in Canada to try to help stave off some of these problems of having a major shortage of workers, let alone the money that Channa mentioned, but even to have the workers to do some of this work.
And I have to give a huge shout out to Miss Jennifer Green from Skills Ontario, that's here, who's a really good friend of mine, and Ian Hawkrow, yeah, there you are, girl. And Ian, the president and CEO of Skills Ontario. We do a lot of work with Skills Canada, Skills Ontario, and all the different provinces. We need to make sure we're bringing skill trades into what we do. And Nexans does an excellent job. I know that Dixon, wherever you are, I know I see you everywhere. You do an excellent job in representing your company and what you do and your willingness of making sure that you're bringing the right people into the conversation, so I really applaud you. But I'm going to bring this to you, Hugo, aussi parce que j'aimerais savoir qu'est-ce que vous pensez.
Yeah, well, I mean, so first, just to echo on your comment, I think making the industry attractive to our future talent is super important. There's not an industry in Canada that's going to have to not deal with the fact there's going to be a shortage of labor, right? So how do you make sure that your sector is attracting talent, that it's compatible with the people coming out of school, and how do we go to entities like Skills Canada and so on to make sure that the trades and the people coming from the schools are aligned with the needs, right? So fully aligned with that. We will also work very hard in Schneider and what we do in terms of making technology is going to attract talent, right? So for example, there's a lot of things that are implemented in the grid right now that have been there for 50 years. Not super attractive for young talent coming out of school, knowing they're going to work on stuff that has been almost obsoleted already, right? So when you put in your technology out there, and the risk is you need to make sure that one, it's cyber secure, it's future-proof, and also it's going to be able to attract the talent that's going to work on it. Because at the end of the day, if you install stuff and nobody knows how to work with it, maintain it, you're in trouble, right? So I think the second piece of my answer here would be, so we know we're going to figure out how to attract skills. We know we're going to put technologies that's going to be future-proof, right? Now, the question is, how fast can we do it? Because the reality in Canada is we're typically a country that likes to see proven things implemented. So we're going to wait until somebody else fails, and we're going to try. So we need to shift that mentality to say, let's be early adopters, let's take a risk here, because speed needs to be part of the equation to hit our targets.
Can I ask you following, because you just made a really good point. I believe that failure is the best way to success. And I just want you to kind of pick up on what you said, because I think that you were really driving that force.
Yeah, so this is a tough question. So obviously failure in the grid is sometimes and often not an option, right? I mean, the damage, the cost is not something we can afford. But there's ways to do tests and no proof of concept in a controlled manner where you're going to test the technology, you're going to prove and learn from it, and once you've got that, you run with it. And then the time between testing and testing again and double checking and then implementing sometimes is a problem here, right, or a challenge. So how do we go from testing, fixing it, and running with it?
That's a brilliant answer. And yet, Chana, yeah, Jérôme, Ali?
Yeah, sure. My point, and I don't want to escape the question, but I believe that the opportunities are much, much, much higher than the risk. And we discussed with Tim, I mean, opportunities on modernizing the grid for industries, for utilities, for public, for private, it is absolutely, absolutely huge. And my second point is that I always thought that the rate or the level of digitalization is so low. I don't want to jump from a low level to a cyber risk. You know what I mean? Because on every substation that could be some sabotage, or there could be some hardware damage that could be used as electricity is a common goods, and then people realize that they can have a blackout of outage. And my third point is that once again on opportunity, as mentioned by Kara, digitalization of the grid and the needs of electricity can lead to a low cost, to a better balance in between night and day, to a better flow in the rate, to decrease the number of investment for cable and then increase the flow on the actual cable, increase the lifetime of the cable thanks to those sensoring. So I think that before we jump into cybersecurity and digitalization, the room for opportunity is huge.
Still remember when my PPE gear and my arc flash suits when I was building wind farms never even they were loose. It was never part, but at that point I was never even thinking of cyber threats. I was thinking, I'm like, am I going to make it alive out of that construction site, out of that substation? So I appreciate that. With that being said, I do want to say, because I know that we're starting to run out of time, and I really want to talk about the impacts that every single one of you bring to the table, and especially reflecting on Nexans and the important work and the dialogue that they're doing, not only here in Canada, but on a global scale, which really excites me, Tim. And I keep telling you this, you're awesome, your entire team's awesome, I think it's great. So I just wanted to ask, from each of you, for what your lasting remarks are for the audience, because you have had such an important dialogue to carry. You've had a lot of important theses and interventions throughout this discussion. So maybe we can start with you, Channa, and then with you, Kara and Jerome, and then you go at the end.
All right. Maybe if you don't mind, I'll comment on the previous question as well.
Sure.
So in terms of threats, another thing that we should be thinking about is severe weather. We started the conversation talking about having to build. But then if you look across the country, especially in the summertime, much of the infrastructure is being burned down because of wildfires, right? And there's so many severe weather events every year in Canada. So I think that is an issue that we need to focus on. And that gets me back into your question, Joanna, in terms of the role of regulators. Because the economic regulators that we have, and when I talk about economic regulators, I'm talking about the Ontario Energy Board, BCUC, Alberta Utilities Commission, those economic regulators, they are the ones who will ultimately determine what the customers are going to pay. But most of the time, the innovations that we want to do or the investments that we want to make the system more resilient, withstand severe weather impacts, make sure the system is reliable when the customers need power. A lot of those decisions are going the other way than what we want. And those are not being approved in a timely manner. So if you're thinking about a clean energy future that is resilient, that is clean and intelligent, use all the terms, you need economic regulators to support those investments, to support risk-taking. And that is not really happening at the speed that we want. So we need to build really quickly, but the speed is not there because we need governments and then we need regulators to act decisively and make decisions with speed.
Thank you, Channa. I couldn't agree with you and echo more with that. Kara?
Yeah, that is a big barrier to adopting of any kind of technologies. I'll take a more optimistic view that there's a lot that of low-hanging fruit of things that we can do. That consumers can do, that we can all do individually, that can really add up to something. Now, it's not the same as building the grid, but each of us can make a decision, that actually can make a pretty big impact. And so I would just say that I'm optimistic that we will, that consumers will make some of these choices. Like I got a heat pump, and I've got an EV. Now, maybe I'm like an early adopter, electricity nerd, but as these prices come down, and I'm the type doing it because I care about the environmental impact, but as the prices come down, people will do it because the economics make sense. And I am optimistic that that's going to happen in short order, and that will actually, once the consumers are on board, the regulator's going to follow. You know, they're not innovators. You know, they're going to follow. So I'm optimistic it will happen.
I love your optimism, and it's going to happen because it takes everyone hands on deck. So, you know, you've got my support.
So Nexans manufacture and install cable practically all around the world, many countries, and I have studied the grid, electrical grid in many countries, in Europe, in Africa, and South America. And I think that Canada is unique. Canada is unique as a country and as citizenship, but the grid is unique. And my dream would be that Canadian grid could become in the next 15 years as a worldwide benchmark. Because of first, the strength, which is zero carbon. I mean, the good start with the hydro plus renewable plus some nuclear and natural gas would be perfect. Obviously, you would need to have interconnection in between, especially east and west. But then, carrying on this digitalization on the Canadian grid would make a worldwide benchmark, not only on infrastructure, but on the use, on education, on the respect of these common goods, because that's very, very, very unique. And at the end, if it's more than 15 years, maybe we can add an interconnection between Europe and Canada, would be perfect.
Woo. Wouldn't that be amazing? Oh my gosh. Woo. Yes. And I think, Jérôme, we talked about, how many kilometers was that?
Say it again.
How many kilometers was that between?
6,000, you know.
Oh, that's only, we can do it though.
Skipping a jump.
And you go.
All right. That would be the longest transmission line in the world, would it?
It would.
All right, so you know, I'm going to keep it short. So first, for me, unity, one grid.
Yeah.
Integration, leveraging technology. And let's keep our eyes on the prize, right? And it's all about net zero decarbonation.
Mic drop. That was good. So with that being said, I really want to thank our amazing panelists. I want to thank Nexans. I want to thank Tim. I want to thank Dixon, Chris, Hannah, everyone. I think that one thing that I want to just, for my key takeaway, is that obstacles are always here to be overcome. And together, we will be stronger, and together, we will overcome them. So with that being said, thank you.
Right. Well, it's certainly clear here that there is some work to be done on our part. But it's also clear that we have the tools at our disposal right now to make real change and drive forward into a new era of electrification. That was a pun that was also intended because that's the name of the conference. So, yes, another round of applause. Well, I will say it's been an incredible evening. The speeches, the conversations we've seen today, they all point towards a growing momentum within electrification just all over the world. And in the spirit of E3, part of Nexans' operating model, before we close our event, we'd like to recognize some remarkable team members who have excelled above and beyond in innovation. So now I'd like to welcome onto the stage Guillaume Emery, Chief Strategy and Innovation and Digital Officer at Nexans, to present the following awards.
Good evening. Nexans has been innovating for 120 years. We don't put satellite into orbit, but we bring energy where it's needed. Innovation is part of the job of every employee in Nexans, whether they are in the offices, on the shop floor, or meeting our clients every day. And I have to say it's probably the most exciting part of their assignment. We have a program at Nexans to reward the most innovative teams, This is part of the Nexans Remarkable program in the category Pioneers. So Chris, if you could please call the winners on the stage.
With pleasure. Okay, so I'd like to welcome onto the stage Chavalier Arroyo, Supply Chain and Purchasing Manager of Nexans Brazil, Jose Yancey, Innovation Manager, Centelsa by Nexans, and Christina Gray, Innovation Manager at Nexans Australia and New Zealand, and one more, Attila Curtis, Managing Director, Middle East and Africa, to accept the award on behalf of Anas Kubesh, Technical Manager, Distribution Transformers Casablanca Plant in Nexans, Morocco. One. Picture. Okay, Safia, good? Good, very good, thank you. To close us out, I'd like now to welcome onto the stage Tim King, Managing Director of Power Grid and Power Connect North America at Nexans.
Thank you, everyone. So I want to make a few closing remarks tonight. I do want to begin with thanking our panel board, the moderators. We had Joanna, Carol, and Elliot. I think it was a great job. The panel board participants, I think all of the insights and the conversation for us are meaningful, thinking about not only the challenges that we face as an industry, but the opportunities and how we can collaboratively work together in order to move forward and electrify the industry. I do want to share one note on closing. I had three heroes in my life. Like many of you, my father, Wayne Gretzky, because I figured that if I couldn't skate that well, I couldn't shoot that well, and I wasn't very big, that I too could make the NHL. That didn't come true. And Chris Hadfield. And one of the things I've always heard is that be careful of meeting your heroes. They may disappoint. And I can tell you, meeting Chris and hearing Chris, and I feel it's the collective resolve of the room, you did not disappoint this evening. And a thank you to all of the team that put together this event. As many of you know, it takes a lot of work and a lot of details to pull off an event like this tonight. So I want to say thank you. And most importantly, I want to thank our partners. Coming to Toronto, I know is not an easy feat. Some of you have come from across the country to be with us today. Your support, your commitment, and our collaboration together is what truly is important to Nexans. And without your support, it means our success. So thank you very much. Enjoy the rest of the evening, and we'll see you in the lobby. Thank you.